Okay, welcome to ATAR exam preparation online video. This one we'll be solving question 18 for specialist math, QCAA, external assessment 2020, paper 1, question 18. This is a complex familiar question. We need a long division, using long division and the roots of polynomial to solve A and B. Now, but just have a look at the condition. We need to remember A, B must be integer. So also positive integer. So don't forget it's positive. So we need to find what is the possible values. So it means you got all the possible value for A, B for all the roots, remaining roots. We got one root already decided, but the remaining roots has to have an imaginary component, sorry. So what do I mean by that? So that means we need to have like a plus bi form. So that means you have to have this form. Now this obviously we don't use a, b, because already confused. We use m and n. All right, so let's see how we solve that. Let's first is that we given the z equal to negative I is it's a root. So therefore we can substitute, so plug into polynomial, which is pz, so must be equal to 0. So we substitute into that. So you can use the I, etc., simplify. So therefore we found that because equal to 0, so b must be equal to 4. So we already decide b value is 4. Then we know because of the conjugate, because of the q to the power 4, so the other root must be positive I. So positive and negative I is a pair. So that's a conjugate. So we plug in to also equal to 0, must be equal to 0. So we try to see if it's right. So we verify that, plug I into the function. So this is a 4. So we also prove that was true. So therefore we got two roots plus z plus I, z minus I are factors of, because they are roots. So we need to say the factors of pz. So if that's the truth, we can write pz equal to 2 brackets, z plus I, z minus I, times by a constant, z. So we don't know what q is. So that's the remaining, so that must be quadratic. So those two together become z plus 1 times by qz. So therefore qz must be pz divided by z squared plus 1. So how do I find a qz? I'm using long division. Now this time I'm using all the coefficients. So the z plus 1, z squared plus 1 are using, so that's a square term, plus 0z plus 1. All right, the ring side, the pz, that's a 2z to the power 4. So that's az. That's a cubic term. This is a square term. So we line up. So all the numbers, coefficients line up. Last one's plus 4. So now we're going to use long division. So first, so we need to line up a quadratic, so square. So 1 times 2 is 2, 2 times 0 is 0, so 2 times 1 is 2. So if you haven't done a long division, you might have to revise the long division. So basically you find that so So needed 2 divided by 1 is 2. So that's how the 2 come from. All right, so then subtract 8, take away 0 is A, 6 takes 2 is 4, and A move down. So then we do another long division. So the next one should be A divided by 1. So therefore we got A, so A 0, 8. Subtract 4, 0, 4. So then your last one will be 4 divided by 1. So get 4. So the answer is 404. So the answer is 0. So that's good. So therefore this is the one I wanted. This is a QZ. So therefore the QZ is 2. So remember the first one is a square term, QZ plus AZ plus 4. So that's my QZ. So in order to have a Z, in order to this is the remaining roots we can find it from the quadratic. In order to have that quadratic have 2 imaginary roots, we need the determinants or discriminant must be less than 0. So therefore you have an imaginary component. So therefore we have a squared minus 32 less than 0. So we factorize into less than 0. So remember, if it's less than 0, we can use, that means the Z must be between negative 4 square root 2 and the positive square root 4 square root 2. However, we know A must be positive, so therefore we exclude that. So it means we need to determine all the positive integer between 0 and the 4 square root 2. So that's the condition we are given. So therefore we work out there's all the values available is 1, 2, 3, 4, and the last one's 5. So A can be 5 values and B will be only 1 value. So that's it. That's solving solved this complex familiar question using long division and also using the roots theory. So remember division. And also the factors. So don't forget the factorizing the polynomial. Okay, so hopefully this will be the solution for you, and please give us the thumbs up if you understand the solution, and don't forget subscribe channel for the latest video. I'll see you next time. Bye.